All right, everyone, this is take two. My microphone wasn't working last time. Okay, or I don't know why. So this is the circuit that we worked on with the inductors, the RL series circuit. Notice where I have my oscilloscope probes. One is on top of or at the top end of the resistor, and the other one is at the top end of the inductor. And we're going to notice that if we capture this on an oscilloscope, we're going to get a phase difference. Now again, everything is on, and notice I'm not using the built-in oscilloscope from National Instruments to the instrument launcher. All right, so if I come right over here, my instrument launcher is on, but I'm only using the function generator. Today's demonstration is just to kind of show you how to do this on the hardware with the actual oscilloscope. Okay, so I'm running this at 1 kilohertz at 2.83 volts peak to peak, and my probes, if you can follow it up, go right up to my oscilloscope. Now I'm using a Tektronix TBS 1072B-EDU edition. So that means it's an educational edition. We pay a little extra for this just because we can actually load teaching modules within the oscilloscope so people can actually follow the modules and learn about the oscilloscope themselves. All right, I've created one module already, but I don't think y'all have the exact same model. All right, so you can see here that we have two channels on the oscilloscope, and this is a two-channel oscilloscope. And notice that the waveforms are so condensed because we have a very large time scale that I can't even make out a single waveform or a period of a waveform. So in order to zoom in on the horizontal axis of the time frame, I'm going to go ahead and work on the horizontal control, which you see is labeled here on the oscilloscope. Every oscilloscope has these labeled. Right, so you don't have to look for it, but just you have to understand the concept here. This is too tight, it's too compact. I have to like zoom in. So imagine I can pinch in and zoom in. So I'm gonna have to actually go in and break it down into a smaller time increment. So what I'm gonna do is right over here, not the position, but the scale, the time scale. I'm gonna go ahead and adjust that time scale so that I can zoom in. Now I've got both waveforms on here, so whatever I do is gonna affect both of them. There we go. I'm going to do one more scale. In fact, let me read this as I adjust it. So right now I am on, what is it, 10 milliseconds? 5 milliseconds per division. Notice I'm getting smaller and zooming in. Right, 2.5 milliseconds per division. I'm zooming in a little bit more. That's 1 millisecond per division, so I'm zooming in a little bit more. I'm going to keep on going until I get just a few waveforms in the on the graticule so I can actually measure the period. Okay, so that's another one. See, I keep zooming in, and is that as low as it goes? That's 500 microseconds. Oh, 250 microseconds. Let's see if we can go a little bit lower. And that's too far because I need a full waveform on the screen. Notice that the frequency, the cycle RMS, those are now with a little question mark. The period also has a little question mark because there's not enough on the screen for this to measure. But if I go back the other way, all right, so now I got waveforms, full cycles of the waveform on the screen. Now it's going to show me the frequency that's measured, which is 1 kilohertz. I don't know if y'all can see that. Let me, do I got a pencil or something? I sure don't have a pencil. Okay, I'll go back to the finger. All right, so 994, 1 kilohertz. The RMS is about 477 millivolts. That is for channel 1 because it's labeled as 1. And again, I only have channel 1 measurements up here. That's just the way whoever had it set up last did this. One peak-to-peak voltage is 1.38, and then the period is 1 millisecond. Right? And it tells me channel 1 is at 500 millivolts per division. Channel 2 is at 1 volt per division. Now let's see what happens if I put them at the same scale. So 500 millivolts and 500 millivolts. Let's do that. So I'm going to go ahead and check on 2 here, which is blue, right? That's my blue signal. And I'm going to change that volts per division to 500 millivolts from 1. So let's see what happens. Oops, went too far. There you go, 500 millivolts. Now let me see if I can adjust it. Now I'm going to put this channel, instead of oscillating above some waveform down here, above some baseline, I'm going to center that at 0. Kind of move that up. Right there. Okay. And then channel 1, I'm also going to put it down about 0. Right, the 0 axis. So I'm going to do that. Bring it down. I'm bringing it down to that 1 gets down there. Right there. That looks about right. Okay, that's cool. All right, so now I want to measure the period of the frequency. So all I'm doing here is phase shifting the frequencies. That doesn't affect the period. So it doesn't matter if I measure the period of signal 2 or signal 1. Let's go ahead and measure the frequency. Well, we already have the frequency, right? And we already have the period, but I want you to learn how to do this manually as if you don't have those measurements. So I'm going to take those measurements off. You know, I'll leave them on there so we can do the actual cursors. So let's go ahead and do cursors. I'm going to hit cursor right here. All right. And okay, I'm just going to leave it on channel 2. And channel 2 is this blue signal right here. So it's the blue waveform. All right. So I'm going to, and the type, just click on that. Do I want the amplitude? So do I want the cursors that are going this way so I can measure from top to bottom? Or do I want the time? So I'm going to have the cursors that go this way. I want to do the time. Now in mine, I have a multi-purpose button. And so as long as I'm on this menu, this multi-purpose button will work, right? That's amplitude. If you can see that lighting up, that's time. Multi-purpose knob / button. So it's a knob, and I can actually press on mine. Oh, I didn't want to move the oscilloscope. There we go. So it's a button / knob, right? Two functions there. So now I've got that. Now notice that these two cursors pop up. We've got one there, and I don't know where the other one's at. Oh, right over here. There's the other. It's hard to see that little blue line. You got the other blue line there. Now what I want to do is manually measure the period. So I'm going to go ahead and move this cursor till it gets to the 0 crossing. And I'm going to move the second cursor till it gets to that 0 crossing at the end of one waveform. So let's go ahead and do this. If I can remember this correctly. Okay. So I'm going to, there we go. So right now it's automatically selected to the first cursor. And so I didn't have to push the button. So I'm just going to do that, move that cursor until it gets to, right, oops, too far. Right there, it's as close as I can get. So that's going to be the beginning of the waveform. Now I want this other cursor to go to 360 degrees at the end of that cursor. So I'm going to go ahead and click it so I can select it. Hopefully that selected it. Nope, I didn't. Try that again. Oops. Back down, back down, back down. Okay. There it goes. Hopefully. Okay, I am not. Or don't do that? No, I don't have to do that. That's not it. I turn that off. Okay, my second cursor should be moving. And the power just went out. Oh, you know what? I actually turned off the cursors. Okay, time, source 2. Oh, sorry, that's right. I'm on. So for mine, yeah, there's soft buttons. It's a combination of soft buttons and R buttons. So right, it was already defaulted to cursor 1. Now I'm going to hit this button here, the soft button. That's going to take me to cursor 2. Sorry, that's how you turn it to the cursors, which is good. You saw me making that mistake. Get this menu off. Hopefully you have the same oscilloscope. So now notice I can move the second cursor. I'm going to move that second cursor right there. Again, as close as I can get it to 1. Get it to 0. And again, so we're going to have some error based on our actual measurement techniques. All right, so now we look at the frequency that we're measuring. So here we got channel 1, 2 microvolts, 1.005 kilohertz as our measurement for this channel. And that's it. That's it. Now what I have over here is the, give me a second. Am I looking at the wrong one? No, they're both at the same frequency. I don't have it displayed yet. Sorry, okay, that's that. Now let's actually do cursor and go back to that. Here we go. Now we can actually see what our measurements are. That's 1 millisecond. The difference is 1 kilohertz. And I'm about as close to 0 as I can get, right? Now notice as I move this, it's actually, that'll actually change. 998 microseconds, 1 kilohertz is going up. Yeah, right there. And so I don't want that. Let's put this back down to 0. You got to get comfortable with your oscilloscope. You may have soft buttons like this. You may have a bunch of hard buttons where everything's just knobs and buttons. But all oscilloscopes have the exact same functions. It's just that this one happens to be a combination of soft menus and hard knobs and hard buttons. All right, so my measurement will be right there. 900 microseconds, 20 millivolts. And I'm measuring the frequency, the period from here all the way to there. Now if I make it a little bit more, sorry, right there. I'm sorry, the measurement's up here. 1 kilohertz, 0 volts. That's cursor 1, that's cursor 2. Again, I keep doing this. All right. And I'm just gonna keep the recording like this because I don't mind if I make an error here or there. It's good for you to see me do this and work my way through it. And that's all. And every oscilloscope, you just got to get familiar with where the functions are at. All you got to know is that I have a phase difference between these two signals because of the inductor. It's not going to cause any change in the period, which means it's not going to change anything in the frequency. So if I measure the frequency in the period of the yellow waveform, it's going to be exactly the same as the blue waveform. Nothing happens except for the phase shifting, and that's all. And that's what we want to get the difference of. So now we got this phase, we got the period of this measured there. Now what if I want to measure the time difference between one waveform and the next? Right, so what I can do is look at the time that this waveform crosses 0 when it's going up, and the blue waveform's crossing 0. Or, yeah, I'll just move that one over here. So I'm going to do this. Right. And I'm just going to do right there. Now I know the amplitude is not the important part. Where it's actually crossing the horizontal axis is what I'm looking for. So I'm trying to get that first cursor right on that 0 axis right there. And I am going to get the time difference, here we go, between that and that. So the time difference is 100 microseconds. Don't worry about the frequency between there. That's only if I had a waveform that was moving that fast. But the time difference is what I'm looking for, that delta t, that delta right there, and time. So that's 100 microseconds. Now you can convert 100 microseconds using your formula into an increment of angle between 0 degrees and 360 degrees. And so you can figure out what 100 microseconds would be equated to in an angle, and that will give you the exact angle difference between the source, the function generator source, and the waveform at the inductor. Hopefully that helps. All right, I'm going to upload this, and hopefully that helps.